In this example, we want to determine if the system created by x minus 4y plus 3z equals 4 and 2x plus y minus z equals 6 is consistent or inconsistent. Well, we recognize that those represent planes, and so the first thing we ask ourselves is whether or not the normals are parallel. The first normal is 1, negative 4, 3, and the second normal is 2, 1, negative 1. Therefore, the normals are not parallel. And because the normals are not parallel, we have a line of intersection. Because when you have two planes in 3 space, if they're not parallel, they must intersect along a straight line. Sometimes people say, well, what about if they just intersected at a point, if the corner of the plane hit? But planes don't have corners like that. Instead, the length and width of the plane are infinite. And so what we have is a line of intersection represented as best we can by that line where those two pieces of cardboard meet. So what we want to now do is figure out the equation of that line, and we're going to do it using matrices. So the first thing we do is we write out the coefficients. We have 1, negative 4, 3, 4, and 2, 1, negative 1, 6. We're going to multiply the first row by 2 to give us 2, negative 8, 6, 8, and 2, 1, negative 1, 6. And now we're going to be able to subtract. We're going to subtract row 1 minus row 2. And once we do that, we might as well reduce 2, negative 8, 6, 8 back to 1, negative 4, 3, 4 by multiplying row 1 by a half. So we do that. We get 1, negative 4, 3, 4. And then our second row is row 1 minus row 2. So 2 minus 2 is 0. Negative 8 minus 1 is negative 9. 6 minus negative 1 is 7. 8 minus 6 is 2. 0, negative 9, 7, 2. At this point, we can't simplify. We can't get any more zeros in this row using our elementary row operations. So we let y be the parameter t. We could have let z be the parameter t, but we let y be the parameter t. Now, going back to this line, we know that negative 9y plus 7z equals 2. Well, that since y is t, that would imply that negative 9t plus 7z equals 2. We can now solve for z in terms of t. We try to isolate the z, we get 7z equaling 2 plus 9t, which means z is 2 sevenths plus 9 sevenths of t. Now what we can do is move up one level to this row and try to isolate the x. Well, x minus 4y plus 3z equals 4, subbing in a y value of t, and a z expression of 2 sevenths plus 9 sevenths t, and letting it equal 4, leads to this next line, distributing the 3. Isolating the x leads to x equaling 4 minus 6 sevenths plus 4t minus 27 sevenths t. Using some common denominators, we end up with an expression for x of 22 sevenths plus 1 seventh t. So now we've got three parametric equations, a parametric equation for x, a parametric equation for y, and a parametric equation for z. So we summarize them as follows. Now looking at this, we can see that our direction vector is 1 seventh, 1, 9 sevenths, because it's the coefficients of the parameter. So a direction value is 1 seventh, 1, 9 sevenths. We can multiply through by 7 since it's a direction vector, and we can say it's 1, 7, 9. So the line of intersection is the point that we know, which is 22 sevenths, 0, 2 sevenths, plus t times the direction vector of 1, 7, 9, where t is an element of the reals. So do we have a consistent or inconsistent system? Clearly we do have points of intersection, and they are along that line, which we've determined to have that equation. So in summary, we can say that we have a consistent system. There are an infinite number of points on both planes, all lying along the line shown there. And you can see I made a mistake the first time through, but that should be the correct answer.